welcome back to class. This is Master Builders Academy, an online tutorial class where we teach is art to help YX students, JAM students, NECO students, 100 level, 200 level, A level students, and so much as so on and so forth. Guys, please, if you know this is your first time in viewing our video, watching our videos, please do well to subscribe to this YouTube channel and ensure that you hit the notification bell for you to be notified anytime we upload mind-blowing content. Now, guys, in this tutorial class today, we are going to be looking at Surds. All right? Yes, we're going to be looking at Surds. We have it on the board already. Now, guys, before we can start solving problems in Surds, we need to first of all know what is Surds. Yes, what is Surds, guys? Surds is a mathematics of roots of numbers or elements. Yes, it is the mathematics of roots of numbers or elements. Now, surds are irrational numbers. Surds are roots of rational numbers whose values cannot be expressed as exact fractions. Guys, what are the examples of surds, or how do surds look like? Now, examples of surds are root 2, root 3, root 8, root 20, root 50, root 800, just like that. These are examples of surds. So when you look at this, you will see that the numbers here inside the square root are in themselves not perfect squares. Yes, they are not perfect square, but in it or in some of them, you have perfect square as a factor of those large numbers. Hope you are here. So surds are surds are what? Irrational numbers. They are expressed as the root of what? Rational numbers whose values cannot be expressed as exact fractions. Now, there are basic operations that are being carried out in surds, and these are what we are going to be looking at in this class. Now, guys, before you can be able to solve problems in surds effectively, there are basic rules that you must know. Of course, if you check some textbooks, you will see 2 rules, 3 rules, 4 rules, 5 rules, as the case may be. But in this tutorial class today, we are going to be giving you 10 basic rules that when you acquaint yourself with these rules, guys, you are going to gain mastery over these topics in mathematics. Surds is going to be under your foot, and it's going to be like a child's play when you know this rule. So we are going to the board and start deploying the basic rules that will help us to carry out every necessary operation in surds. Now, when we talk about operations in surds, we are talking about addition of surds. Just like I have this now and I have this, I can add 2 or more of these surds together. I can subtract more of these surds from each other. I can multiply 1 or 2 surds, 2 or more surds. I can divide 2 or more surds. These are the basic operations. But before you can be able to carry out addition, subtraction, division, and multiplicational operation in surds, there are basic rules that you must know. And these rules are the secrets that when you hold it by your hands, or when you have it with you, you become an exceptional student when it comes to the issue of surds. In fact, you will not have issues in solving problems on surds. Now, guys, let's get started. Rules of surds. Now, rule number 1, we have that the square root of A times B. Let's assume that A is a number and B also is a number. Both are positive number. So the root of A times B can be expressed as the root of A times the root of B. This is the law of multiplication. That when you have 2 numbers multiplying themselves inside one square root, that you can separate them and having each of these numbers have their different square root. Are you there? Yes. So this equation is vice versa. This rule is vice versa, right? So you can be given this and express it to this format, or you can be given this and express it to this format, depending on the nature of the equation. Now, rule number 2. Rule number 2 is that when you have the square root of A over B, everything inside one square root. It can also be the square root of A over the square root of B. So you can also share the square root for the numerator and also give it to the denominator. Yes, that is what it means. So you can be given this, and if need be, you can transform it from this particular state now to this other state, or from this state to this other state, depending on the question that you are given. Then another one is rule number 3, is when you have the root of A times A. This would have given you A. Alright? Yes. When you have the root of a number multiplied itself inside a square root, the outcome is one of the numbers. So if I have the root of 2 times 2, the answer is 2. If I have the root of 8 times 8, the answer is 8. This is exactly what this rule is all about. Now let's head on to looking at rule number 4. The rule number 4, we have A times root B. Now, in this scenario, only B is inside a square root. So, when you multiply a number outside square root with a number that is in the square root, all you have is A root B. Please, it is an error for you to have root of AB. It is very wrong. A number that is not inside square root cannot multiply a number inside square root. Hope this is gotten yes. A number that is not inside square root cannot multiply a number that is inside square root. So therefore means that a whole number cannot multiply an irrational number. Are you there? Now that is all about that particular rule number for now, guys. What could have been our rule number 6? Right? Now, rule number 5. If we have A over root B. Now, in this case, only the numerator, only the denominator is carrying the square root. The answer to this would have become A root B over B. When we get to the process where we'll be solving this effectively, or we'll be using this theory, I will explain better. But understand that what we do here is rationalization. So when we get to that part, I will explain it in details. Alright? So first, understand that anytime you have a square root at the denominator, you must rationalize. So the process of rationalizing, all you just need to do is to multiply both the numerator and the denominator with the denominator that you have. Are you there? So when you do that, you are going to have this as the outcome of the whole scenario. Now, next we do is rule number 5. Rule number 6. Now, guys, what could also be the rule number 6? Rule number 6, if I have A over B plus root C. This is exactly the same thing as A into B minus root C all over B squared minus C squared. This will also be explained when we start solving problems effectively. These are rules. So what you do to get this is to what? Rationalize. All you do to rationalize is to multiply both the numerator and the denominator by the conjugate surd of the denominator. So what we mean the conjugate of the surd, we are actually talking about changing the signs that connect two surds, or a whole number and a number in surd. So what we do is that to rationalize, you change this positive sign to negative sign, and that's all you have. You use it to multiply both the numerator and the denominator. When we get to the point where we'll be applying these theories, you will understand better. Then rule number 7. Rule number 7, we have A over B minus root C. Now in this case, now this question comes and the denominator will now have minus. Now in this case, I'm going to have A into B plus. So the conjugate of this is changing this sign, connecting these two fractions, so these two numbers to positive opposite sign. Then all over B squared minus C squared. This is it. So the denominator doesn't change, alright? Because the conjugate, this you are multiplying by the conjugate, so the denominator remains the same. Then rule number 8. Guys, this is very, very simple, alright? It is very, very simple. So now, guys, let's look at rule number 8. Now, rule number 8 simply states that if you have A root B and you want to express it to a simple form or a simple surd, just to leave your answer is you're going to have this as root of A squared B. So when you are taking a number outside a square root, inside square root, you will square the number. Hope you understand this, yes. this is 2, this is a. Now, if I am taking this a outside the square root to the square root, I will affect it with what is square. So I'll possibly square the number. And when I have this square, therefore, I am good. Then likewise, we have rule number 9. And in this case, if I have the square root of a plus b, mathematically, root a plus root b. This cannot be split as this. So when I have the root of a plus the root of b, this is not equal to root a plus root b. You do not split a numbers that are separated with multiplication, sorry, addition sign or subtraction sign inside the square root. So in this case, root a plus b is not the same as root a plus root b. Alright? Then finally, rule number 10, which is the last but not the least, is root a minus root b is not the same, it's not equal to root a minus root b. What this rule 9 and root 10 is stating is that there should not be a time where you should separate the square root for the two numbers you have inside square root when they are connected either with addition sign or subtraction sign. So these are the basic rules that we get to know, you need to know as a student to be able to solve problems on sorts effectively. Now guys, what is the next thing we should look at for? Now the next thing is what we want to quickly look at, the conjugate of what? Surds. Guys, the conjugate of surd is actually changing the sign that connects two surds. Yes. If it is plus that is connected to surd, the conjugate of that surd is negative. For instance, if this is called a conjugate of surds, so if I have root a plus root b, the conjugate of root a plus root b is root a minus root b. So all I simply do is to change the sign that connects the two surds. Are you there? Yes, this is what we did. Then secondly, if I have root a minus root b, the conjugate of root a minus root b is root a plus root b. This is it. Then what happens if I have minus root a plus root b? What will be the conjugate of this number, guys? The only sign that changes is the sign between the two surds. So which is the sign that connects the first surd to the second. So therefore, we are still going to have this as minus root a, then minus root b. So the only sign that changes now is this middle sign that connects the two surds. Then also, what happens if I have the root a plus or minus root b, or when I have minus root b? Guys, this is exactly the same thing as what minus root a plus root b. What happens here? We only change the sign that connects the two surds. Hope this is gotten. That is the conjugate of a surd. So when you are asked to find the conjugate of a surd, all you just need to do is to change the sign that connects the two surds to the opposite sign. So if you were given plus before, the conjugate of plus is minus. Why the conjugate of minus is plus, vice versa. And this is basically used under the division operation of surd. So when you are dealing with operation of surd under division, that is when you actually put the conjugate of surd into consideration. Guys, then the next thing we quickly do before we start solving problem is to look out for the classification of surd. Yes, you know, I like giving us classification so that you know where to go, what to do, and where you need to know what to do and what is expected of you as a student. Now, guys, we look at classification of surd. Now, guys, what are the classifications of surd? Now, surd is also classified into 3 categories. Yes, they are classified into 3 categories. Now, number 1 category is the simple surds. The number 2 category is the compound surds. While the last but not the least is complex surds. These are the basic classifications of surds. So why I'm giving us this tree diagram or this flow chart is because our calculations or our solvings will be based on this. So when you understand the concept of simple solve, compound solve, and complex solve, solving problems in solve will not be a problem. Now, generally, every solve, every mathematical problem you are given under solve is expected to be at least in its lowest form, right? Yes. So that lowest form of solve is what we call the simple solve. For instance, if I have root 2 is a simple solve, or 2 root 3, these are all simple solves, all right? Now we have what we call the compound solve. This compound solve actually deals with addition and subtraction of solves. Yes, the operation of solve, that is addition and subtraction, is categorized under the compound solves, right? Yes, they are categorized under what? Compound solve. Now, how do this come? You can have this as root 20 plus root 32, or you can have this as root 75 minus root what? 48. As the case may be, this is an example of what? A compound solve. Now, anytime you are given a compound solve, what is expected of you is to reduce this compound solve to a simple solve, either in this format or in this form. Are you there? Yes. Either in this form or in this form. You must reduce these to either this first format or this second format, depending on the nature of the question and the parameters or the figures you were given. All right. Now, finally, we have the compound solve. Under the compound solve, this is where we look at the multiplication and division of solve. If, for instance, you are given the root of 75 times the root of 24 all over the root of 200. You see now, this is a compound. See this aspect now. This is the complex aspect of solve. All right. Now you can also be given, maybe you are given 3 over root 3 minus 1 plus root 3 over root 5 minus 1. These aspects are the complex aspect of what? They are the complex aspect of solve. So, guys, for you to be able to solve every solved problem effectively, you must know that this is where every question you are given is to be landing. All right. So your final answer must be as simple as any of these. All right. Can be as simple as any of these, or maybe 2 plus 3 root 2. Any of these now is a simple aspect of solve. So anytime you are given a problem called solve, you first of all need to know, categorize it to know the class it belongs, so that you will know the step to take. So if I am given this now, I already know that there's only a few things I need to do here. But if I am given this, I need to put some steps into consideration before I will be able to reduce a compound solve to a simple solve. So understand that first, you must reduce a compound solve to simple solve for you to get your final answer. And also, you will also need to reduce your complex solve first to compound solve, then from compound solve down to complex solve. So if this condition is understood, guys, then the next thing we are going to do is to dive into solving problems and solution. And now, what you quickly do is to go down to the description below and you will find the link to the next video where we will solve the very first problem. Now, understand that in this solves problems and solution, we are going to solve problems not less than 25. Yes, we are going to be solving problems not less than 25 in this video class. All right, in this our online tutorial class, we're going to be solving at least 25 questions. So understand that these 25 questions are not going to come in one video. They can come in 2, 3 videos or 3 questions per video. But all these 25 questions must be solved, and you will always find the link to the next video after you have watched the current video. Watch it, just go down to the description and you will see the link to the other video. Now the next